In this video, we are going to learn about the mechanism of hydration of alkene. So this is the third mechanism in the chapter of alkene. Now let's proceed. Okay, so we have this propene reacts with acidified water, and of course we are going to get this product. So this is the product that we are going to get. Now let's see the mechanism to produce this product. So for this we have the first step, which is the formation of carbocation. Now here, it is almost the same like the previous one, the hydrohalogenation. However, the reagent this time is acid, which is hydronium ion. So we have this hydronium ion. So what will happen here? This bond will undergo heterolytic cleavage, and both of the electrons will be given to O to produce H2O. This H will somehow become H plus, and since it is H plus, therefore this double bond, which is rich with electron, will attack it. Will attack the H plus and to produce this. So of course, according to the Markovnikov rules, between carbon 1 and carbon 2, H will go to carbon 1. So H will go here. And again, for carbon, since it has 3 electrons surround to it, therefore it becomes positive. So this is our carbocation. And if we classify it, it is secondary carbocation. As usual, you stop, you see, you consider whether the carbocation will undergo any rearrangement. But for this one, this is actually the most stable carbocation for this structure. So there will be no rearrangement. Then we can proceed to the next step, which is the attack of nucleophile towards the carbocation. Okay, so in this point, water will come. Okay, so what will happen? This lone pair, okay, it will be donated to the carbocation, and thus proton will be formed. Okay, so dia akan jadi like this. Oh, sorry. So as you can see here, we have 1, 2, 3, 4, 5. And oxygen will be positive. Then we go directly to step 3.
Help me! Help me!
So here it is. Okay, so we have this one here. And what will happen here? The water will come. Okay, and then this part, okay, this part will undergo heterolytic cleavage, where both of the electron will be given to O. H will become H plus, and thus this electron will attack the H plus. And we are going to get this. Going to get back the H3O plus, and we are going to get alcohol. Okay, that's it for the mechanism of hydration of the hydration of alkene to form alcohol. Now, let's proceed with the next question. You can try this first, and later on you can pause and try it first, and later on you can continue. So for this one, we are going to get this. Okay, we are going to get this one. So how does it happen? Let's proceed. And we have this hydronium ion. Okay. So again, what will happen? This bond will undergo heterolytic cleavage. Both of the electrons will be given to oxygen to produce water. This H become H plus, the electrophile. And so, this nucleophile will attack the electrophile to produce so the H will go here, and 1, 2, 3. We have 3 electrons around the carbon, which is not enough, and thus make this carbon become positive. So we have our secondary carbocation. As usual, stop for a while, look at your carbocation and see whether it can undergo rearrangement or not. So in this case, yes, it will undergo rearrangement. So the rearrangements here is 1,2 methyl shift, where you are going to get this. So the positive is here. We already get tertiary carbocation. Now next, the nucleophile will attack the carbocation. So our nucleophile here is H2O. So this lone pair will attack the carbocation to produce this. Okay, so if you look properly at this side, we have 1, 2, 3, 4, 5 electrons around to it. And since oxygen has 6 valence electrons but only have 5 electrons around to it, thus it become positive here. And so, for the last step, the loss of proton to form alcohol. So how can the proton be removed? So the water will come. Okay, so what will happen? This bond will undergo heterolytic cleavage. Both of the electron will be given to oxygen since oxygen is more electronegative. Thus, we get this. Okay, we get 2 lone pair back. Okay, however, this H will become H plus and it is not stable. Okay, it will not stand alone and therefore water, okay, will donate these 2 lone pair, take the H plus to produce the hydronium ion back. So only 1 left, and as you can see, we have 1, 2, 3, 4, 5. Thus, it makes it positive. So there you go. The mechanism of hydrations of alkene to produce alcohol.